Hello, AP Environmental Science students. This is Mr. Balsiger. I was hoping to have a quick video to help you do this tricky calculation of biodiversity. First, let's start by looking at our formula. Would you write this down in your journals? We'll have to figure out how to use this and decode this information. Now, this in particular is called the Simpsons Diversity Index. And for this one, it's probably the easiest one to calculate, but it falls apart if you have very low richness. If you only have one species or two species, it doesn't work quite as well. But it's the one that we're going to use. There's lots of different ones you can try. If you enjoy this process, you could go and find another example to use. Let's start by trying to decode all of these various figures in the calculation. First off, you have N and capital N already decoded for you on the sheet, but let's now talk about D really quick. For D, this is going to be the amount of diversity present, and the D values range between 0 to 1, where 1 would be infinite diversity and 0 would be no diversity. And you can imagine that there's a range of diversity in between. So this value, when we get a D of 1, would show perfect 100% infinite diversity, and that's what we're going to use to calculate. This little symbol here is the sum of. And so when you see that, you know that you're going to add all of the little n minus 1s times the little n. And if you see little n is the total number of organisms of any particular species, where capital N is the total number of organisms of all species. So let's look at this sample. I'm going to show you the sample shown on your worksheet for a species of sea holly sand. Check out how this formula works. I'll walk you through the example that's on your worksheet, and then you can double check to see if you're doing it correctly by doing the example that doesn't have the solution for you. So over here, I've pasted in the data table that you actually have on your worksheet. You have all the answers in it, and so I was going to walk you through this set of numbers to try to figure out what everything means. Now here you can see that you have sea holly, sand couch, and so on listed. For you, obviously, you're going to have different organisms, and you're not expected to be able to identify them, but you could imagine if you saw organisms that looked like this, you had some red ones, and maybe there's some blue ones. In your data table, for our actual investigation, you're more than welcome to say, all right, when you're counting these, you might say, all right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 little red koala bears, and I have 1, 2, 3, 4, 5, 6, 7 little blue koala bears. Those will be the numbers of little n that go in your data table. Little n means how many of each of these individual organisms. So you aren't expected to be able to identify the organisms that you actually capture, but you'll be putting them in as little n's. In other words, this researcher counted 2 holly, 2 sand couch, and so on. Next up, what we're going to do is we're going to figure out the total. The total is the same value as n, capital N, excuse me. You can see capital N is listed below. So to find capital N, or the total, we're simply going to add up the columns here. So 2 plus 8 is 10, plus 1 is 11, plus 1 is 12, plus 3 is 15. So our value for capital N is 15. Now, this column gets a little trickier. See the values here is, in this column, we're going to go n times n minus 1. Some of you will be able to do this in your head rather easily. I'm going to write out each one so that it becomes clear. So we take our n value here and we multiply it by n minus 1. It looks like this, 2 times 2 minus 1. Or in other words, that's the same as saying 2 times 1. And so then this value is actually 2. that makes sense, for the n times n minus 1. If you look on your worksheet, you can see that that's the only number written there is 2. Now let's take this next one. If 8 now is our little n, and we want to do n times n minus 1, basically we're going 8 times 8 minus 1, or that's the same thing as saying 8 times 7, or that's the same thing as saying 56. So you can see on your worksheet, the first value is 2, the next value is 56, and so let me write those values in. Now 1, this one's kind of strange, 1 times 1 minus 1, or you can say 1 times 0, that's going to be 0. This one is also 1 times 1 minus 1. And now we have 3 here, so we're going to go 3 times 2, and so this would be 6, and in the end, we'd end up adding up all of these, this one plus this one plus this one plus this one plus this one, will actually represent the sum of all of the n times n minus 1s. 2 plus 56 is 58, plus 6 is 64. So our value for all of the sum of the n times n minus 1 is 64. Now we've got these two values figured out. That's not too difficult. Let's try to put it into our diversity formula that we've been practicing, or that we're beginning to practice. So what this is, we're going to have...
see if I can get rid of this stuff. Very high-end eraser. All right, so we're going to have D, diversity, equals 1 minus the sum of all the n times n minus 1s divided by the total number of organisms times the total number of organisms minus 1.
So that is our formula. I often forget in the end to go 1 minus this value, and so that's kind of a trick. So I'm going to write it again with some of the values in there. This is like saying D equals 1 minus, and how do we figure out this upper value here? We've already have it in the table down here. We already figured out that the sum of all the n times n minus 1s, the lowercase ones, is 64. So in here, I'm going to say 64 divided by, we have not figured out this value yet. Capital N, we figured out down here, that's going to be 15. So I'm going to say 15 times 15 minus 1. That's shown right here. So if we simplify that a little bit, D equals 1 minus 64 divided by 15 times 14. And we can go a little bit further. Feel free to use your calculators on this particular assignment. We have a D equals 1 minus, and in my calculator I'm going to go 15 times 14, and I get 210. So we're going to end up with 64 divided by 210, 0.30476, so on. And that you might think that's the answer there, but don't forget this. We're going to take this. We're going to go 1 minus that to get our diversity. So I'm going to round that to 0.305. I'm going to round appropriately at this position. So in my calculator, I'm going to go 1 minus 0.305, and I end up with a diversity of 0.695, or we could say a diversity of 0.70, and so that is going to be our Simpson's diversity index. If you remember, we talked about where that is on the spectrum. 0.7 is a pretty diverse ecosystem. Now try the one that didn't have a solution on your worksheet on your own, and I'll post the answer in just a minute while I solve it as well. You should pause the video here. All right, I'm back. I solved the n, and I also solved the sum of all the n times n minus 1s for the data table on your worksheet that starts with bat star. So we'll call it the bat star diversity. So unless I've made an error, which is possible, I make errors sometimes, I have found that capital N, or the addition of all of the organisms found in the total environment, was 60. And then when I added up all the little n times n minus 1s, I ended up with 688. So if you got that as well, maybe I didn't make a mistake. So now if we want to put that into our diversity calculation, which is 1 minus the sum of all the little n times n minus 1s divided by the sum of all the big N times n minus 1s, that would look like 1 minus 688 divided by 60 times 59, or I'm going to go to my calculator here. 60 times 59 equals 3,540. That's going to be my value there. So I'm going to go 1 minus 688 divided by 3,540. So 688 divided by 3,540. I end up with, inside of the parentheses, 0.194 continues. Don't forget the 1 minus. So I'm going to take 1 minus 0.194. Having difficulty, 1 minus 0.194, and I end up with a diversity of 0.806, or you could say 0.81 is my diversity for bat star. So if we go back up to our original chart, you can see if I did my math right here, 0.8, is that more or less than the diversity of the sea holly example? That's all I have for you. I hope that was tolerable. Can't wait to see you all.